Welcome back to our third episode on Grade 12 Financial Mathematics. In the previous episode, we discussed future value annuities. So to remind you again, on a future value annuity, we make monthly payments, and at the end of the time, if it's now 5 years or 10 years, you get your money back plus interest. Now, unfortunately, we don't always have the money to save for a period of time. So we would like to take a loan because we want to buy something now. Now that is what is called a present value annuity. Now within a present value annuity, you get the money today, that is your loan, and then you pay it over a period of time, say 5 years. So it is really important for exam purposes that you must be able to identify these questions. When will it be a future value and when will it be a present value annuity? Easy to remember, future value, you pay first and then you get the money. Present value, you get the money, the loan today, and then you pay it back over a period of time. Let's now look at the formula that we're going to use to calculate present value annuities. First of all, the present value of an annuity is defined as the collective value of all payments exactly one interval before the first payment. It is important to understand that in present value, we can't make our payment immediately like we did in future value. In present value, we must have that little gap, that is the one interval before the first payment. So that interval depends on how interest is calculated or how the payments are made, which is normally in a loan, it is a monthly case. This is the formula that we use for present value. You will see it's called P. X bracket 1 minus 1 plus I. Please take note of the minus n over I. And just for interesting sake, why the minus n? And that is the reason because we are working backwards. So if you think of your formula on compound interest, if you want to work out P, you're going to divide by the bracket and then that exponent of n becomes minus n. I hope it makes sense. I can quickly just write it down for you, and then you will see what I mean. If I say A is equal to P, 1 plus I to the n, and I want the initial amount, not the amount at the end of the period, then it means I'm going to divide both sides by the bracket. So that means P is equal to A over 1 plus I to the n. And this I can write as A 1 plus I to the minus n. And just to give you an idea why that is a minus n in our formula. And it's because we are working back to present. So future, we are working from present to future. We make payments, then we get the amount. In present value, you have the money first and then you pay it back. But we must have that interval, that one interval. The present value formula is used whenever the large amount is paid first with payments and the payments are made later. This includes all loans. It is also used when a sum of money is set aside in order to make regular withdrawals in the future. So let's now look at our first example, and I think it will make more sense once you look at this. In the first problem, it says Mpo can afford to pay back at most. So that is the maximum that he can pay on his car loan. It's 8,000. He will be happy if he can pay less, but not more than 8,000. And that is on a car loan. The interest on the car loan is 15% per annum, compounded monthly. So please take note, it's compounded monthly. So this amount that he's paying back, the 8,000, that is X, our monthly payment on this loan, the 8,000. I, which is our interest rate, is 15% per annum, but it's monthly. So 0.15 over 12 for our I. He will make his first payment 1 month from now. So very important. So if I can just show you how this works on a timeline, then I say T0, and that will be T1, T2, T3, and it will go to T60, and maybe you wonder where I get the 60 from. If we continue reading, we will say he will make his first payment 1 month from now, and he will repay the loan over a period of 5 years. So 5 years N is 5 times 12, which is 60 payments. So the important thing to notice is that his first payment is not at T0. That is where present value is at T0. That is where you get the loan. Then a month later, he starts to pay 8,000 and 8,000, and he continued to do so, not 800, but 8,000. He continued to do so right for the full term of 5 years. Now they say, what is the price of the most expensive car he can afford? So what the question is about is to find P. What is that initial loan that he is supposed to take to buy this car? So we say P is equal to X bracket 1 minus 1 plus I to the minus N. Please don't forget the minus N over I. It's a very common mistake. And now we substitute. We are looking for P, so that means we can just substitute the rest, and that is 8,000. 1 minus 1 plus my I is 0.15 over 12. My exponent will be minus 60. Remember, 60 payments, but there's a negative. And then 0.15 over 12. And we now need to put this onto our calculator. The whole thing, like I said before, put it on a bracket. Please exercise this, that you don't make mistakes in the exams. And I hope you agree with my answer. And that is 336,276.73. So the most expensive car he can buy, if you don't want to spend more than 8,000 Rand per month, and that is 336,276.73 cents. Right, so that will take us to our next example. And of course, you notice already what happens. They ask in the first question that we must find that present value, that loan amount. Now, as you can see, the loan is given to you. Jenny wishes to repay a loan of 150. So that is the loan. So we can now say for sure that P is equal to 150,000. So that means they're going to ask us now to calculate maybe his monthly payment, or they can also ask us to determine how many payments, which is N, where we use logs. So let's see what they want in this first part of this question. He want to repay this loan by means of 16 equal quarterly payments. Now guys, this is important to remember, that they say quarterly payments starting 3 months from now, and that sometimes confuses people. The interest rate on the loan is 21.5% per annum, compounded quarterly. So you notice the payments are quarterly, the interest is compounded quarterly, and that's what we said right from the start with annuities. They must always be the same. So the question is, calculate what Jenny's quarterly payment will be. So I hope you agree with me, we are looking for X. So now it is important that we realize that this 16 quarterly payments represents N. That will be 16. They told us how many payments Jenny is going to make. And then your interest rate 21.5, you will see 21.5% is 0.215. And now we divide not by 12 like we very often do, but we divide by quarters, and there are 4 quarters in 1 year. So we divide by 4. So if we look at the timeline for this particular problem, and this is T0, T1, T2, T3, and this will go to T16, I want you to be aware that this from T0 to T1, that is 3 months, because that represents a quarter. So that's a quarter, a quarter, a quarter of a year. So that is 3 months. So then hopefully you understand why they said that, let me just get it again, by means of 16 equal quarterly payments starting 3 months from now. Remember T0, that is where the loan is, P. This is now, the first payment is 3 months later, that means a T1. That is why we call it 3 months later, which sometimes is confusing. But remember, we don't work in months, we work in quarters. So let's write down our formula and let's substitute, and let's see if we can work out what her monthly payment will be. So P is equal to X, 1 minus 1 plus I to the minus N over I. My P is 150,000. X is what we want to calculate. So I get 1 minus 1 plus my I, 0.215 over 4. And that is with an exponent of minus 16 over I, 0.215 over 4. All right, I hope you're still with me. That doesn't look like a 3, it's supposed to be a 3. Right, now it's a little bit of manipulation so that we can get to X. So what we set in future value as well, first multiply with that denominator, and then let's divide by the whole bracket. So we can now easily say that X is equal to the 150,000, that was the loan amount, times by 0.215 over 4, and that we divide with that whole bracket of 1 minus 1 plus 0.215 over 4, exponent of minus 16, and that is my denominator. Please put this whole thing on your calculator and see what you get. My answer for this one is 14,212 and 35 cents. So what does this answer mean? This means that if Jenny wants to make only quarterly payments, only 16 quarterly payments, to pay back a loan of 150,000 at an interest rate of 21.5% compounded quarterly, she's supposed to pay every quarter 14,212 rand and 35 cents to achieve her goal. In our next example, you can already expect what we're going to do there, because in the first one, we worked out the present value. This one, we calculated X, the monthly or quarterly payment. And now we're going to, in the next one, we're going to solve for N. So let's look at, before we get to N, let's just look at the B part of this question. Calculate the total interest that Jenny will pay on the loan. We will get to that calculating N just now. Calculate the total interest that Jenny will pay on the loan. So what we need to take is, we need to look at the total payments. And how do we find the total payments? We take the quarterly payment of 14,212 and 35 cents. And there was 16 payments. And if you multiply that, you get to a total of 227,397 and 60 cents. So that was the total payments over that period of time. She made 16 of them. Now, the question in this one is, what is the interest? What is the interest? So to find the interest, I think it will make sense to you that we take the total payments, that is the amount that she paid onto this loan, and we subtract the original loan from it. Remember, you pay back the loan as well as interest. That is how future value works. So if we know the total amount of the payments, we can subtract the original loan, then that will give us the total interest that she paid on this loan, 397 rand and 60 cents. So as you will notice that on a loan of 150,000, she's going to pay 77,000. That is more than 50% of the loan. She's going to pay in interest on top of the loan to determine the interest, and that is what she will pay back. In the next problem, I want to move on to what I said before, to calculate N. Let's read this problem together. Carl has to pay off a loan of 75,000. So the loan amount is given to us, 75,000. So I hope you agree with me. I can say P is equal to 75,000 rand. He can afford to pay 1,500 per month. So X 1,500. That is what he can pay back. The interest rate is 60.2% per annum, and it's compounded monthly. So we can say I is equal to 0.162, and please take note, we divide by 12 because this is a monthly calculation. And now they want to know how many payments. Please take note, in annuities, N represents the number of payments. In compound interest, it was the number of months or number of years. Now we work on how many payments. So let's start to substitute this information into our present value formula. So P equal to X bracket 1 minus 1 plus I to the minus N over I. So that means if we substitute, we say P, no, we know what P is, so if I can just remove that P, and we can now say that P, which is 75,000, is equal to my monthly payment of 1,500, 1 minus 1 plus my I, 0.162 over 12, and my exponent is minus N, remember that is what we want to calculate, over I, which is 0.162 over 12. And now we need to do manipulation here. Remember, we want to get to bracket to that exponent so that we can use logs again. Remember, always when we need to solve an exponent, we use logs. So I will take the 75,000, I will multiply it with the denominator, and I'm going to divide by the 1,500. So that will give us 75,000. We multiply with 0.162 over 12, and we divide by 1,500. And this will be equal to 1 minus 1 plus 0.162 over 12 with a minus N. Now please take note that this bracket, which we want on its own, it's got a minus on the outside. So best way to deal with this is to take this whole bracket to the left-hand side, and it will become positive. And this left-hand side, we will take across to the right-hand side. So at the same time, I want to calculate the value of the inside of the bracket, and please use your calculator for that. And the answer you're supposed to get is 2027 over 2000 to the minus n is equal to 1, that's still that 1, minus, because I take this whole thing to the other side, this whole term, this whole fraction rather, and I just say 0,162 over 12, and that is 1,500. So now we can simplify this right-hand side. So we still have the 2027 over 2000 to the minus n is equal to, and put this whole thing on your calculator, and I hope you agree with my answer of 13 over 14. Now we're going to use logs again. Please take note, my exponent is not n, but minus n is equal to the log of that 13 over 14, and this big number with 2027 over 2000, that is my base. So that means you can solve this on a calculator, fairly easy, and you will get a negative answer here of 83,81. So you hopefully agree with me that we can now say that n is equal to 83,81. Please remember how many payments. So if Carl is going to make 83 payments, you hopefully agree with me that there's still an amount outstanding. So that means the total number of payments, we expect already will be 84. But how will these 84 payments work? There will be 83 payments of 1,500. Of that 1,500, that will be 83 of them. And because this is not an integer value, it means the last payment will be lesser. So it is plus one lesser payment. Now, in this particular problem, they didn't ask us to calculate that lesser payment. In our next lesson, we will discuss how to calculate that lesser payment. This is now, if your payment per month is fixed, normally you don't get an integer as an answer for n, and that means we must work out that last payment if the question asks for that.